Hello, this is Dr. Rody, and in this video I'm going to show how to use the TI84 calculator to perform an independent samples t-test with pooled variances. We're going to use the pooled test if the population variances are assumed to be equal. So usually in the problem you're going to be told that. If you are not told in the problem that the variances are equal between the two independent populations, or you don't have overwhelming evidence to suggest that that's the case, then you want to use the unpooled test, which will be in a separate video. This is the pooled test. The only difference is when you're in the command, you either put a yes or a no for pooled. So let's begin. Here we have data showing weekly sales for a new cola at random stores depending on the location of the display. So this is a new product and it's put at the end cap in a grocery store, and one end cap is near the beverage where the beverages are sold and the other is near where the produce is sold. And the test that we're trying to run is to say, is there a difference in the average weekly sales depending on which end cap these are sold at? Now, what we have are two independent samples. So these two different populations that I'm looking at, beverage end cap or produce end cap, are considered to be completely independent of each other. And so we're going to use what's called an independent samples t-test. So independent samples t-test. And sometimes called a two-sample t-test. And in this case, we're going to do pooled because we're assuming equal variances. So in essence, we're assuming sigma squared 1 is equal to sigma squared 2. Okay? Now what we have here is a sample from these independent populations. So that's why we're doing a t-test, right? But we're going to assume that they have equal variances. So our null hypothesis in the two-sample test, independent samples test, could be that, or is that the means between the two groups is equal to each other. The two population means are equal. We're testing whether there's a difference. So here we're going to say not equals is our alternative. Well, this is oftentimes how we write it. However, mathematically, this is actually what we're testing mathematically. We're testing that the difference is either 0 or not equal to 0. However, you'll see the hypothesis written that way a lot. So we're going to let the end cap with the beverage end cap, be our population 1. So I'm going to call my sample statistics for that x bar 1, S1, and N1. And then for the produce section end cap, I'm going to call this x bar 2, S2, and N2. So what I need to do is put this data into my calculator and then calculate the summary statistics to get these values. So what we want to do is put this data here for the beverage end cap into list 1 and the data for the produce end cap into list 2. So I'm going to do stat, edit, and then there's the data. So what you want to do is pause the video and type in this data and then restart it when you're ready. Okay, so now that my data is in here, what I want to do is run one var stats on each one. Now these happen to be the same size. If your data sets are the same size, you can run two var stats. But a lot of times with independent samples, you might have different size sample sizes. They're not necessarily always the same. So I'm going to run stat calc 1var stats on list 1. And so my X bar for list 1 is 50.3. My standard deviation S for the sample is 18.73. I'll take 2 decimals here. And then my N is 10. So now I do again stat calc 1var stats. And if you have an 83, you have to do comma, then L1 or comma, then L2. But here I'm going to do second 2 to say L2 and then calculate. And so my X bar 2 is 72. My S2 is 12.54. And my N2 is also 10. Now this difference here is pretty big. It's 22. But is that difference big enough to be considered statistically significant? So now we're going to run the independent samples t-test. So in order to run the independent samples t-test, I'm going to type stat and go over to tests, and it's number 4, to samp t-test. Number 4, that is what often is called in other software packages the independent samples test of a mean, or t-test. So I have it on stats. So I'm going to go in here for X bar 1, that's 50.3. For S1, that's 18.73. N1 is 10. Then X bar 2, I type in my mean for population 2 from the sample mean from population 2, and then standard deviation 12.54, and then my N2, which is 10. Not equals is my alternative, and in this case I'm going to say yes to pooled, because this is discussed in the book on page 323, and also this data you'll find on page 325, but they want you to assume equal variances. Now you will be told in the homework on the math lab problems, it'll clearly say whether you have equals or not, and if it says nothing, then you have to look at the standard deviations. But if you don't have overwhelming evidence to assume that they're equal, then you're going to use unpooled. But in this case, we're going to use pooled because we were told that they had equal variances, or to assume so. And so then now I'm going to hit calculate. So here's my test statistic T, which is negative 3.04. My degrees of freedom here are 18. It has the summary statistics there. And what I need to find is my p-value. Right here, 0.00697. So 1, 2, 3, 4, right? If I round to the 4th decimal, that will go up. So my p-value is 0.0070. So if we have, let's say, an alpha of 0.05, well, 0.0070 is less than alpha, so then we would reject HO, right? There is sufficient evidence that the mean weekly sales are different, right? So in this case, we reject the null hypothesis in favor of the alternative.